Some teachers go rogue sometimes, but oh well, what can you do? Okay, so just do one together, and then I want to let you guys try one on your own. Ooh, I like it. Let's do this one. Where'd it go? Bless you. Okay. That does look sort of heinous. But our whole purpose at first is to try to make it look less heinous. It would look less heinous if I had no fractions. So that's what I'm actually trying to do. What is going to allow me to get rid of my fractions here? What part of this problem allows me? Yes?
Multiplying by x.
But what allows me to do that? What allows me to get rid of my fractions? But, alright, so if I had 3 over x plus 1 minus 2 over x plus 1, can I get rid of the x plus 1s?
No.
Hell no. Because it doesn't have...
Equal.
It doesn't have two sides. When I have two sides, I can multiply, divide, add, subtract both sides, and the balance remains. That's what allows me to kill my fractions. So once I show a few of these, people suddenly start killing fractions everywhere. Holy shit. No. I like it. Alright, maybe. So here, though, what I do is, what's the very first thing I should probably do?
Multiply by x.
Yeah, how can I start to build my LCD? I have to know what everybody has. So what does he have on the bottom? X minus 1. What does he have? What does he have? It's hidden. Shit. So that's the first thing I should do, is to see what everybody has. So if somebody's hiding shit, this guy's hiding shit.
He has both.
Yeah, he's got both of them.
Yeah.
So you factor any bottom that you can, so you can really see what they have, and then compare what they have to what everybody else has. This guy's hiding what he's got because he's got a lot. Like, open that damn door. So we open the door, what do we find? I like it. Right. So we are the very aggressive Robin Hoods in here. Open the damn door, give me your money. So then, what's this guy missing?
X plus 1.
X plus 1.
And then X plus 1.
And this guy's missing X minus 1. So on the top and the bottom, that's the legal way to do it. Stop there for a second. I mean, let that be nice. Factor, and then just give everybody what they're missing relative to other people, other things, other bottoms. Alright. So now that I have all the bottoms the same, and it's an equation, I'm allowed to multiply both sides by x minus 1, x plus 1. So that would distribute to both of these. It would kill this here, and it would kill this here. And we let that absorb. Yes, sir.
We're going to kill the other
And
side.
it'll kill over there too, I like it. So then what am I left with?
X plus 1 plus x minus 1 equals 2.
I mean, that's almost too nice to believe. It looked so heinous. And then we made it look more heinous for a second. But we did that so that we're legally allowed to kill all the bottoms. And now it looks nowhere near heinous. This is chapter 2 now. Now you just solve it like normal. Don't think anything's changed. Just solve it like normal, however I do. Yeah. Now, here's the new thing. I think we talked about this last time, but it's been a while. There are certain values of x that don't work here. In fact, this is the very first thing we talked about when we got into chapter 7. There are certain values of x that I can't use. What values of x can I not use here?
0.
I can use 0 all day.
No.
Positive 1, negative 1.
Positive 1, negative 1.
Negative 1.
What did we just get as an answer?
1.
Shit, can we use that?
No.
So the only possible answer is 1. I can't use it, so there is
No answer.
no solution. There you go. Now, real quick, I want you guys to understand why this is, because math is hard enough already, and then it's giving us wrong answers, and you're like, what the hell's wrong? So we did everything right. We did everything right, and math gave me an answer that's wrong. You damn stupid. No, it wasn't math's fault. What did we do right here? We multiplied by this, didn't we?
Yeah.
But if x is 1, what is this?
1.
No.
0.
0.
1 minus 1 times 1 is 0. Can you multiply both sides of an equation by 0? No, you can't. Did we know it was 0 here? No. This is math going, shit, you did something illegal. Do you see what I'm saying? So I understand students already don't like math, and then when we hit these problems where they're giving us answers, math is giving us answers that are wrong. You're like, I even hate it more. I didn't think it was possible. It's not math's fault. There's no way for math to tell us except this. Well, if you could do that, then I can let x be 1. Oh shit, I couldn't do that. No solution. I like it. And why do equations sometimes have no solution? Because they're set up and they're bogus to begin with. That example I gave you, Johnson, how can I make $15 billion at my lemonade stand next year? You're not going to. Here's the math. Impossible. Shit. Right? You set up an equation. If the answer comes out no solution, that means whatever that was impossible. I love it. And that's real life. Alright. So I might have taken too big of a step here with this problem. So let me dial it back for a second. What would I do on this problem here? Yeah, multiply by 7. So that's the basic idea we're employing. It's an equation. I'm allowed to multiply by anything I want to except 0. So of course it's going to multiply by 7, because everything's being divided by 7, right? So this would be 7, 7, 7. Don't actually make this 35, because the 7 immediately wants to die. Don't kill it and then have it stay there. I mean, look at that. I'm like, oh man, shit. It's dead. What's left here?
X minus 3 equals 5x.
And that's beautiful. Right? Tears, you know? Right? And then what do you do?
Okay.
Minus x.
4x. 5 by 4.
So x is negative 3/4. Now what's nice when the bottoms are numbers, is there any way that the bottom could be 0? Can 7 ever equal 0? No. So any answer you get is not going to be making it undefined. When the bottom has variables in it, oh shit, some values can make it undefined. So I've got to check them at the end. Do all the work and at the end go, does that make anybody freak out? Yes? No solution then. Okay, so let me give you guys one to try. So do that one. It's a lot like the one we just did. So I don't know if you picked up on this yet or not, but there's a lot of fantastic hints in these problems. I mean, that's going to factor to be
2x plus
that
1, 2x
times that.
minus 1.
Oh, not always. Be careful. They might slip one in that's not exactly like that, but that's the first place I'm going to look. That times that is that is sweet. So that is this. So who's missing what? What's he missing?
2x minus 1.
He's missing
2x plus
x plus 1. And he's missing
nothing back.
none. So then
Multiply by
multiply.
2x minus 1, 2x plus 1.
And if you're really careful, basically, if you make everybody the same, you can just cross them all out. Because, right?
Yeah, that's what I was gonna ask. Like, can I
Totally.
skip
Just
that?
don't get overly optimistic. It's got to be an equation, and they all have to be exactly the same. Every single denominator has to be the same. Then, basically, what's going to happen is that's going to cancel with all. It's going to multiply both sides. It's going to distribute to every term. All the bottoms are going to cancel. So I'm left with what?
2x minus 1 plus 2x plus 1 equal to
So this is almost exactly like that one we just did. And then my terms
4x minus 1. X
Oh.
equal.
minus 2. How did I get that? That
One
should
of
be a
those
plus.
is plus.
Thank you,
Yeah, I
thank
was
you.
gonna say, I'm like, what is it?
Thank you.
Yeah, 4 equals 2.
So
And then
x equal
1/2.
2
X equal
over
1/2. Kick your ass.
4.
Is that okay?
Yes.
You said that with such confidence.
Yes.
Immediately after my comment, that was supposed to let you know that that was wrong.
Wait, that's
Oh.
not.
What's that?
Oh.
When you plug in a half, what do you get right here?
Here's 0.
2 times a half is 1, minus 1 is 0. What makes these 0? What makes 2x minus 1 0?
1/2.
X equals 1/2, yeah. Right?
So
Oh shit, that's what we got. So,
No
no solution. That's what I mean. You work it all out. You don't worry about that till the very end, but the last thing you do is, will that make anybody 0? If it doesn't, it's fine. It doesn't mean it's the right answer. You're not checking it. You're just making sure the answer you got doesn't freak anybody out. So we didn't just check the answer. We saw if it freaked anybody out. If it does, it's definitely not the solution.
What about the plug it to x plus 1? Like 2.
Totally, that's beautiful. But does it make any? If it makes any bottom 0, that's what matters, right? If it makes any bottom 0, then that's going to be undefined. Right? And then you say, well, what's 4 plus undefined? Well, shit, that's undefined. So it doesn't matter if it works somewhere. All it needs is one place that it doesn't work. And the whole thing is shit. Well, 4 plus 3 plus infinity, well, that's a problem. Right? So that's what really happens when you try to plug something in. The bottom becomes 0, that's going to infinity is really one way to look at it.
Because, yeah, I check
You can't
it.
do that.
I only check it with the first fraction.
Ah, okay. That'll do it. All right, maybe. One more of those. Just early. Huh?
What section is this?
7.6.
7-6, yeah. We're about to get into chapter 8. Holy shit. By the way, I forgot. Somebody will remind me. I've got the complete fall schedule and summer schedule. So somebody will email me. I don't think I emailed myself. I was going to email myself that spreadsheet, and I don't think I did. Anyway, so tomorrow we can look at who's teaching when, and we can talk about, off the record, who to maybe stay away from. Right? I'm sorry.
There were only 3 1/10s that I checked on.
Oh, over the summer, yeah, right? Yeah, over the summer. There's only 3, but I'm talking about fall also, so people won't take anything over the summer. I've got the fall schedule too. So somebody remind me. Let's see.
Email you.
Oh, there you go. All right. So here, this is the one I want to do. Where'd it go? There.
Yeah, that's great.
Can we identify an immediate place to be careful? No. Okay, let's see if we pick it up on the way. What's the first thing I do? Oh,
Well, you can put it 1/1.
there you go. You want everybody to have a bottom so you can see if the bottoms are the same.
Factor.
Now I can factor. I like it. So identify your whole numbers. People sometimes just leave them out entirely, and that's not legal. If you multiply anything by both sides, it's going to happen here also. So you need that to show up. So now I can work on all the bottoms. Like Jan said, how do you factor this here?
X minus 3, X plus
So what's he missing?
3. X plus 3.
X plus 3. What's he missing?
X minus 3. X
Everything.
plus 3.
Like, oops, leave that there. So multiply top and bottom by everything that they're missing. Since that middle dude was a whole number, he had nothing on the bottom except 1, so he's missing everything. So now I can basically, again, be really careful. I'm going to multiply with it so it cancels, cancels, cancels. Since it's an equation, I can do that. Don't get optimistic and say you can kill every fraction. You're not that powerful. Right? Can't find that sword in the game. It doesn't do it. So what am I left with here?
3 x 3 plus X plus 3 plus X minus 3 equals 6.
Careful now. What's in the between those?
Multiply.
Multiply.
Oh,
Right? And I might as well go ahead and multiply this out, right? That would just become this again, right?
Yeah.
Is that? Do you guys see that? So I can get my like terms together. Might as well just multiply that. Equals 6. All right, try to finish that up. Let's see if you remember. This is a little different because of that. Just to be very blunt. This x squared piece tells you something. It tells you how to solve this. Hopefully.
Ja, klopt.
No. X squared plus. Plus X. Sorry. Still thinking.
Keep it to yourself. Yeah. Alright, so make sure everybody's going on the right track. The next immediate thing, because of this, what do I want to have happen? I want it to do it.
Get all the same. Turns
So
the light.
you want it to equal,
No.
you want it to equal 0. There it is.
Yeah.
Whenever you have a power higher than 1 on your x, so you can't put your x's together. They're not like terms. So you can't solve it like normal. You get it equal to 0 and factor whatever you're left with on this side. So what can I do on this side first here? I get x squared plus x
Minus 6.
minus 6 equals 6. Now here's where people kill the 6's. That's a neat trick. What do you do to make this 0?
That's 6. Minus 6.
That would make it 12. Subtract 6. So on that side I get 0 like I need. And on this side I get x squared plus x
Minus 12.
minus 12. Yeah, they don't cancel, they combine. They're both negative. But what told me to do that was the x with a higher power than 1. There's an x squared in there, so I want to get it equal to 0 so I can factor. 0 is the only number that will help me. So how do you factor this?
Minus 12.
Minus 6.
No, minus 4. Plus 4. Plus 3. Minus 2.
Positive 4.
There it is.
Positive 4.
Positive 4, negative 3. 4 times negative 3 is negative 12. Positive 4 minus 3 is positive 1. You just need factors of 12 to add b1. Different signs, so it makes it possible. So then x equals
Negative 4.
negative 4 and 3. Is that cool right there? Is that, yes? Is that okay? Is that good, the answer? Now I've got 2 things to check. Do they both work? What's not allowed? What x's can I not use?
3.
3 and negative 3. So what is
You can't use that. 3.
So 3 is no good. Negative 4 is the answer. Because negative 4 doesn't make anybody freak out. So sometimes you can get an answer because you get 2 and one of them die. One of them's no good. You have to make sure that none of your answers makes the original equation freak out. That's all. Can't use 3. Makes this guy freak out. Can't be the solution then if it makes it freak out. Solution's supposed to make it work, not freak out. You guys with me on that? So however many answers you end up getting, you got to look at each one of them and say, is anybody, so at the very beginning you could say, x can't be -3 and 3. So when you get to the end, you're like, let me see, oh shit. You don't have to wait till the end to do it, to be honest. At the very beginning, you can identify what x values don't work. Okay, yes sir.
So if 3 were the only answer to this problem, then it would be no solution.
Then it would be no solution.
But because there's a no solution in there, we know it's -4.
Exactly. So there were 2 options, and one option didn't work, so the other option's good. I like it. Why were there 2 options? Because I ended up with a square that tells me I'm going to have 2 answers. The other ones we did so far, there were no squares. I only had one answer, and that answer happened to not work. Now don't freak out. It's not going to happen a lot. You should get answers most of the time, but sometimes something's not going to work. Throw it out. Don't just not write it, because then I'm worried that you didn't even see it was an option. Write it, cross through it, circle the other one. If it works, yeah. Okay, good. All right. So, any questions left over from chapter 7 before we transition into chapter 8? It's like it's almost the end of the semester or something. Oh, shit. May just came out of nowhere. Yeah, we don't do 7-7 here. And what I was going to say earlier, we're right now in the overlap with the next. So Math 103 and 110, they're both going to start with a review of factoring and then go through chapter 7. So like, remember we skipped 7.5? I don't know if you guys remember. That's going to be in the next. So you'll just start, you'll have a review, which is nice. So the first week or so, you'll have stuff you've already seen before. Beautiful. You get a little deeper in some of it. You'll do some sections we skipped, but at least it's all stuff that you're used to. And then you get to the really freaky stuff. Okay. So chapter 8. So let me ask you something silly. If I went around to everybody and asked, what size shoe are you currently wearing on your left foot? Now I have to be really careful like that because some people might have different sized feet, and that sucks for them to buy shoes. So my point with this is, so if I ask you, do you know what size shoe you're wearing on your left foot? 7, okay. If I went around to everybody, what would you think of the person if I asked somebody and they said 6 and 9? Does that make physical sense? What would that mean? They are currently wearing 2 shoes, and that doesn't make any damn sense. So the idea we're about to get into, I know you've heard this, I've said this word probably before. We're getting into the idea of functions. And the main definition of a function relates to what I just said. For every input, each of you would be an input, and your answer would be the output, right? So you would be you're the input, and my question was size shoe, and you said 7. So my input was Melissa, and the output was 7. So every single person here for that question, you would have one answer. I like it. And we would say, if you're not wearing shoes, number 1, what the hell, get out of here. Number 2, you just say 0. I got a 0 size shoe because it don't exist, right? If you had no shoes on. All right, how are we doing so far? So functions have to make physical sense. So for example, I throw a ball in the air, and I say 5 seconds later, where's that ball? If you tell me 20 feet in the air and negative 10 feet below the ground, what? There's only one place the freaking ball can be. So when I throw a ball, what's it look like? I like it. But what's the path it takes look like?
Parabola.
Yeah. So if I'm standing here, so this is how tall I am. I throw a ball. It's parabolic. And then somebody else catches it over there. Hey, thanks, man. One big arm. All right. So everywhere. So every time each of these times, 1 second, 2 seconds, 3 seconds, 4 seconds, so forth, each of those times is an input. They're a question. At 3 seconds, where's the ball? And then the output is the answer to the question. What's the matter? Are we okay?
Yeah.
Does this sound vaguely familiar?
Yeah.
Inputs and outputs, no? But does it make sense then if it doesn't sound familiar? Does this... No? Shit. Are you okay? Were you just shaking your head? Yes, you.
Yeah.
Alright. I was like, damn. Alright. So there's no way in hell that I'd say at 4 seconds, where's that ball? It's here and it's there. How the hell? What kind of ball is that? Is that Star Trek shit? What is that? Ball transports itself? I don't know what that means. Okay. Alright. So what does this mean? Now we need to make this more technical. We need to bring it back down to just pure math. Right? But I want you to realize most equations we work with model real situations like this. Parabola would model the trajectory of a ball.
So the reason your y-axis is the answer is because at what time the ball is where?
Yes, at 4 seconds,
Where?
where's the ball?
Right.
So when is the question, where's the answer? I like it. So that's the traditional classic way. When you get further in math, you start to mess with some of that a little bit because how I put the axis doesn't matter. But the underlying basic foundation is my x-axis is normally considered my input, my question in a way, and my y-axis is my output. My outputs. I like it. Okay, maybe. So for example, here, this could be the t-axis because it represents time. But I know it's like the x-axis. I'm just using the letter t because I want to talk about time. And this could maybe be the
L.
D. Distance.
h for height.
Oh.
I like it. Because we're not talking about how far the ball goes. We're just talking about how high the ball is. I like it. All right, cool. So can you draw me, not draw me, but draw an example of something that wouldn't make physical sense? So this makes physical sense. Even this makes physical sense. Like if I'm on the moon and I throw it hard enough, it's going to leave the moon because the gravity's not that hard. I throw the ball hard enough, it's going to just keep going out into space. So that makes physical sense. So what cannot happen when you graph something? What would make it physically impossible? Okay, I like it, sort of. So for example, this ball, I can't say it's like this. Because that would mean at time 4 seconds, where's the ball? Here, here, and here. Oh shit. I guess get the idea. So basically what cannot happen is a function can't come back on itself. I love it. So even if it's a boomerang, I'm still talking about how high off the ground it is. I'm not talking about... So this picture is not like a picture that I'm seeing the field and I can see the ball moving around, because you're right, I can throw a frisbee and somebody else can throw it back to me. But I've got time 0, 1, 2, 3, 4. So even if it's a boomerang, you can say you throw it up and it goes up and then it comes back to me. It's not going to come back this way because that would mean at like 2 seconds it was in 2 different places. I like it. So later in math, you learn how it's a bit more complicated. To make the graph match what you actually see, you have to use 3 variables. Can we all agree to not do that right now?
Yes.
Let's just keep it with 2. It's because of the way that I've identified the axes. This is time. This is purely time. This is not distance on a field or something where the ball can go like that, of course. I can throw it, somebody catches it and runs the other way. That ball's all over the damn place. I'm talking about just how high off the ground is the ball at certain times. There's no way in hell it could look like this. Because that would mean at 4 seconds, it's at 3 different heights. And if I'm playing football, that's a whole other level of scandal, right? There were 3 balls on the field. Tom Brady. How much time do we have to give you off this time? No, I'm sorry. I hate the Patriots, by the way. All right, I'll be right. So I'm okay with Tom Brady getting suspended. Bunch of cheaters. Okay. So now we're sort of developing a rule here then. How could you quickly identify, so does this seem to be okay? Is this a good function here?
Yes.
Yeah.
Why?
Because they don't
boom.
They don't come back. So is this an okay function here? Of course, right?
Yes.
All right, good. So is this an okay function here?
No.
No. Or a little circle. Can you be more technical in your answer as to why that's true? Give me a test I could do, like a, why is this not good? Because, yeah,
Yeah, and same time here.
for some x value, if I draw a line, it goes through
2 points.
more than once. That's a nice visual test. What kind of line is that?
Vertical line.
Oh, so we call it the vertical line test. It's great. If any vertical line I draw, anywhere, if any vertical line I draw goes through the graph more than once, it's not a function. Because that would mean that somehow that magic ball